All right, welcome back. So in the last video, we were finding volumes of prisms. And in this video, we're going to find volumes of cylinders. But, you know, honestly, it's the same kind of idea, right? If you have some figure where the bottom face and the top face are the same shape and the sides are straight, right? Then the volume of that figure is going to be the base area times its height, right? So let me just make some random looking base. Okay, so we'll okay, and so if we just take that base, lift it up, right, that produces a three-dimensional figure. Okay, doesn't matter what shape the base is, right? I just made a random shape here. Okay, but the idea for volume right now is that if we can figure out the area of that bottom face, and we know how high we've lifted it, right? And we can multiply those two quantities together to get the volume. Okay, so again, in general, the volume is the base area, okay, which I shaded in green, times the height, okay, this vertical height here in red. All right, so you can see here that we have two circular faces, right? We have this circular face on the left, and we have the circular face on the right, okay? I personally much prefer to have it drawn so the face is on top and bottom, not side and side. So I'm gonna redraw this cylinder in this orientation. Okay. All right, so now 9.1 becomes the vertical height, and 5 is still the radius. So again, the area is the, sorry, not area. Mr. Leong's tripping. The volume is the base area times the height. Okay. Now, what sort of shape do we have here on the bottom face? It's a circle. Okay. And so the area of a circle is pi r squared. So that's going to be our formula for the base area times the height. Okay. 5 is a radius, so we're going to have pi times 5 squared times 9.1. And you can just type this into your calculator. Pi times 5 squared times 9.1. And you would get 714.71. I'm going to round that answer to the 10th place. And our units are going to be, let's see, meters for linear units. So meters cubed for volumetric units. Okay. All right. Figure B looks like a cylinder that's just been tilted or slanted. And, you know, the book has an interesting way of thinking about it. It says, you know, think about having a stack of quarters, right? Maybe you have, you know, 10 quarters stacked up, okay? And those 10 quarters are going to take up a certain amount of volume, okay? Now, if you tilt that stack, right, then those stack of quarters are going to have a shape like this. It's a tilted stack, but it's still 10 quarters, right? So it still takes up the same amount of volume, okay? Whether that stack of quarters is standing straight up or whether it's tilted slightly, right, it's still 10 quarters. Okay. So the cool thing here is that even though this is slanted, we can still use the same formula. Okay. So the volume is going to be the base area times the vertical height. So we've got, again, a circle as our base area. And the area of circles, pi r squared. And then the height, well, we know that if we straighten that stack up, right, if we straighten it up, it would be 22 feet high. Okay, right now it's tilted, but, you know, vertical height's 22. All right, so let's plug away. We're going to have pi times, now the radius of this circle, it's going to be the same radius as the top face, 7 squared times 22. Sorry, you couldn't see that. There it is. All right, so pi times 7 squared times 22 is going to be 3,386.64. Okay, and our units, our linear units are feet. So area units would be feet squared, volume units would be feet cubed. All right, cool. So again, just like the last video, right? Figure out what the base area is, right? And if that face has been lifted up and is the same shape as the top face, then you just multiply the base area times the height, and that gives you the volume, okay? And if it is slanted, right, just think about like your stack of quarters, right? Whether that stack of quarters is standing straight up or kind of tilted to one side, it still takes up the same amount of volume.